So this is the first day of the ROS short course, and I just remembered to start the desktop recording. I'm doing this because when I taught this class at Hopkins this last spring, several students felt they had, when we were just reviewing things in class, they felt that some long strings of commands kind of zoomed by them, and they wanted to be able to kind of go back in time and see what was the command that he typed. And so this is a new experiment. I'm going to try recording my desktop and audio during these sessions, and I'll upload them to YouTube at some point later this morning. And I'll be interested to know from the class whether that proves to be a useful resource or not. So that's pretty much the course overview and organization. I thought that maybe it would be good if we went around the room and everybody could introduce themselves. And I'm hoping that you're going to sit next to somebody you don't know at Hui, because Hui is a little bit balkanized by architecture and the geography of the different campuses, and OOI is up here, and who knows what the people are doing in Blake. That's a strange place. So I hope that in addition to doing some programming together and system building, we'll also get to know some folks who are in different orbits of the institution. I'm an adjunct, and I've been an adjunct for 22 years, and a co-PI in several vehicle development projects with folks at the Deep Submergence Lab. 2 years ago, the reason I'm here is that a little more than 2 years ago, I decided to abandon a code base that DSL and I have been sharing for over 20 years. It does include code that I wrote when I was a graduate student and postdoc. And I decided that if I inflicted it on my graduate students, in future generations of graduate students, that I'd be arrested for child abuse, and I didn't want that to happen. So that's why I'm here. So who wants to start?
Hi, I'm Dennis. I work in acoustic communications and Smith.
I'm Jeff Haley. I work in the Ocean Systems Lab in Bigelow.
I'm John Wren. I work at OOI on the mornings of the Quail.
I'm Stephanie Pillow. I also work on OOI.
Jonathan Helm, I work in the Deep Submergence Lab.
What do they do there?
Don't know. Child abuse. Submerged stuff.
Mike Kubo, also in Submergence Lab. Zach Shortwoods, also in Submergence Lab.
David Teixeira, joint program student.
I'm Hickory King, also in Program.
I'm Andy McFay. I don't know what I am, but I'll just mention that one of the reasons this course kind of spread out throughout the institution was because Mark Abbott was interested in was putting a proposal together, and we just got funded. So it's like I'm going to be able to come back half time. And one of the keys to that proposal was the idea of using ROS as kind of a language to talk to each other about systems. We started using it more as an institution. It was a way to start talking between departments, between groups, with kind of a common instrument language of sorts. We should try that out.
I'm Emmett. I work for TV Lab, which does code design.
Ed Hobart, Smith Building, AEL.
Carl Kaiser, mostly Deep Submergence Lab, and various other, some stuff in OSL as well.
I'm Andrew Spielhorn. I'm a fourth year PhD student in Lewis's group at Johns Hopkins.
I'm Eric Bates. I work down in networking.
Jeff O'Brien, AEL, Bigelow.
Gwyneth Packard, OSL.
And File Unity Bedford.
John Ware, AEL.
I think that's everybody. Before we get started, I want to review the sort of set of tutorials for this morning. Folks want to have questions or comments about how things have developed for them so far. I'm just curious to get a little feedback. We were a little disorganized in getting you the image late. It would have been much later if Jeff hadn't spent a bunch of time on it and really made the Ubuntu image happen. So I'm grateful, Jeff. Thank you. Any thoughts or comments on how things are working out for you or not working out for you so far? Yes. Okay. Yep. Sure. You.
No, I'm still between black and blue.
Okay. So the I'll hand around black and blue. Yeah. So I'm going to hand around a black and a blue. There's a 2-board set here and a 1-board set, and the history genealogy of the Beagle board is there was a series of Beagle boards that were fairly large form factor, and then Jason Cridner and a few others got together and they wanted to build a smaller board that would be more I/O rich, and so they designed the original Beagle Bone Black. It didn't have Wi-Fi. It had a big RJ45 connector on it, and a USB port and an HDMI port, and it also had 2 giant connectors for plugging in I/O boards. And the 2-board set that I'm handing around is the original Beagle Bone Black, with what was called the robotics cape, which is a companion board that plugs in with these 2 giant dual-row pin connectors. And the robotics cape was developed by Tom Bewley at UCSD and Jason Cridner and Strassen, and who was Tom Bewley's former master's student. And so Strassen put this out in the public domain, the design, and also several different, since it's in the domain, several people could manufacture the robotics cape, and so you could buy them for, it was like $40. And so when you bought the Beagle Bone Black and the robotics cape gave you serial I/O, SPI/I/O pins, 4 PWM motor drivers, 4 encoder inputs, 8 RC servo drives, interfaces for RC radio input if you wanted to use RC radios. I already mentioned serial ports. So it was a very I/O rich expansion board. And the original Edumip was designed with the Beagle Bone Black and the robotics cape in mind. The robotics cape was designed together with the Edumip. And after they worked with that for about a year, they realized that they could make this, they could down cost the thing by making a new version of the Beagle Bone Black, and it was the new, so blue is the new black. And the blue contains most of the circuits of the original motherboard and all of the circuits of the original daughter board, the cape, all on a single board. And it loses a few things. It no longer has an RJ45. It no longer has a HDMI output, which nobody used. And so for $80, you get both boards, and it contains, in addition to the I/O that I mentioned, the Beagle Bone, the robotics cape, has a 9-axis IMU and a pressure sensor, in addition to being very rich. So you basically get, a little poor man's microstrain for $80, and it runs Linux. So we're using the Beagle Bone Blue, which is taken the circuitry of the black and the robotics cape and squeezed it into one relatively low-cost package. Does that help?
Yes, it does.
Okay. And you still, right now, the one question that has been asked is, is the black with the robotics cape and blue actually binary compatible? The answer is no. They use different I/O ports for a certain I/O, and the robotics cape library is supposed to know which board it's using and make the right I/O calls. Right now, there are still a few bugs with the black, and Richard Nelson has told me that he's going to fix that soon. But in our release, it works well with the blue. It only throws a few errors, and it doesn't work right now with the black. But in a future release, it will. Other questions? Okay. So the thing that we're going to work on this morning, and it's going to be an experiment to see whether we can. The thing that we'd like to cover today are essentially the core components, getting ROS master going, publishing and subscribing, introspecting into messages, using standard and user-defined messages, and a little bit of recording and playback, although that's quite easy, and most important, writing your own ROS node in C++ and getting familiar with the design patterns. So scrolling down to the first module, what I'd like you to work on after this discussion is basically working through these tutorials. And the most important one is being able to navigate the ROS file system, creating and building a ROS package, understanding nodes and topics. Services, I'm not going to spend too much time on because you can teach that yourself. Parameters are important at this point. And creating ROS messages and services. And I'd like you to write a publisher and subscriber in C++. And writing a service and client is optional. And so these are the tutorials that I want. These are the names of the tutorials that I think you should go through, most of them. And in terms of what I actually want you to do, it's listed under here. Assignment number 1 is write and test a ROS package named Beginner Tutorial, comprised of a C++ publisher node and a C++ subscriber node. So these are both going to be mains. And writing a client and server for a service is optional. We do use services still, but they're not nearly as useful as topics. And then what I do in my class at Hopkins is I have, for every module that we do, I have them push a project to Git server. In this case, we don't have access to the Hopkins teaching Git servers because they're behind a firewall here, but we can use GitHub. So if you'd like us to take a look at your package, then I want you to, for Andrew and I to take a look at it and give you some feedback. Then you should push it to get an account on GitHub if you don't already have one. Create a project called Beginners Tutorials, and push your project to that, and share it with us, and then we can take a look at it with you. So this is the morning's activity. We'll see. We'll get calibrated at the end of the morning as to whether we can cover all this. I think this is a pretty sophisticated group, so I think probably yes. Does anybody have any questions about installing and configuring the ROS environment here? Do I need to review this? Because we asked folks if they could to do the first several tutorials, and we haven't gotten any feedback on sort of how that went for people. So any feedback would be welcome. Is everybody able to type ROS core and get ROS core to come up? Yes. Okay. Well then, does anybody want me to review this module? I can. Next one is navigating the ROS file system. I think I do want to spend a bit on this. Just to review over here, when you installed ROS with sudo apt-get install ROS desktop full, these are the modules that have installed. Installed systems directories that were owned by root, and they were in op-ROS kinetic, and they're in osprop kinetic, so you can have multiple versions of ROS loaded at the same time, and depending on which setup.bash that you source here, you'll set the environment variables for that different version. And so this is a pretty sensible way for a binary installation, an on-source installation, and every user on the machine can access it. Obviously, executables are in bin, scripts are here, include files here, libraries, link libraries are here, and share contains other things that are different, such as message files, launch files and things like that. And normally you don't mess with this, so you don't sudo and mess with this directory tree at all. You only interact with it via apt-get install and install binaries. And most packages that you're likely to want to use are available as binaries. And you can also pull down the source so that if you want to mess with the source, then your executable version will supersede the version that's in the system. And the design pattern for developing your own code is that you create a directory called Catkin Workspace or ROS Catkin Workspace. The name doesn't matter. The directory structure below that is that there's a source directory which has a master cmakelist.txt file in it. And then below that, you create packages, package directories, each of which normally corresponds to a single Git repo. Sometimes you'll have several packages in a second level below that are closely related, and that's okay. And then these directories are ephemeral. The build directory, where the system builds the source directories, and the develop directory is where CMake and catkinmake puts the resulting executables. The install directory is if you're doing an installation where the source gets copied someplace other than the development tree, the default place is right here, and you can set an environment variable to make it install other places if you need to do that, if you need to share that, for example, with other users. And all of these directories are ephemeral. If you're having problems and CMake is crapped out halfway through, you might want to blow them away and do a clean compile. And then the structure within a ROS package is package name is under source, and a package consists of a number of subdirectories and 2 files that you'll review in the tutorials. There's in the new Catkin build system, which has been around for about 4 years. This is the design pattern. Package.xml encodes the build dependencies and run dependencies, and cmakelist provides the detailed list of dependencies for this package. And the idea in the catkinmake system is that a package should be very self-contained, and between the package.xml and cmakelist.txt, the dependencies to other packages should be specified. So source is in source directory, includes are in include package name, not just include root, but include package name. Messages and services are we define custom messages, and scripts are for other things, and I've left out launch. There should be a launch subdirectory. So so it's a quick overview of the file system, and ROS CD, which is a nice little utility to zoom around the file system. And by default, if you type ROS CD, for example, if I type ROS CD serial for the serial package, it'll change my directory to it's going to change me to the binary installation of op-ROS kinetic share serial. If I pull down the source code for the serial package, which is a ROS package for doing serial I/O over serial ports, then and I had compiled it in my local workspace, then when I typed ROS CD serial, it would bring me to my local copy under my Catkin workspace source serial. ROS CD log, tab completion. All of the ROS commands do tab completion. That's really useful because some of the names are long, and so I encourage you to make use of it. Creating a package. So this describes in greater detail what I just reviewed in sort of high level, what the structure of a package is. It consists of a top level directory in the source directory, a cmakelist file which is in a particular format that's required by the Catkin build system, and then a series of subfolders. The source is where the source files are. And so if I look at if I do ROS CD by default. It brings me into my Catkin workspace, Devel. Is this font large enough for everybody to see? Okay. Website larger, okay. Better? So right now, these are the packages that I have loaded into my Catkin workspace. And each one of them has a CMake file. And when I go up to my I run Catkin make from this level of the directory. I can see I've got a build and a devel directory, rm-r build. Those are ephemeral directories, and so if I want to do a Catkin clean make, I'll do it here, and it's going to do all the CMake, compiler checks and figuring out whether you got pthreads and all the usual stuff that CMake does. Every once in a while, this will throw an error. If some dependencies aren't perfectly set in the packages, you'll get a dependency error where some messages won't be set. And that arises because normally it runs the same number of threads in the make as you have cores on your PC. And so when you're running multiple threads, sometimes the dependencies get out of sorts. If that happens, like here, then I'm going to do catkin make -j1. So it's going to do the build in a single thread, and so the dependencies are going to be sorted out properly because it's not running the CMake jobs in parallel. And notice what it's doing here. You see a whole bunch of stuff about messages. It's looking at the different messages files that are in these packages, and it's generating header files or source files in Python, C, and Lisp to serialize and deserialize these messages in all of those languages. So that was a clean catkin make. You create a package. You're going to create a package called Beginner's Tutorial, and you're going to do that by CDing to your source directory and use the catkin create package command. And this creates an empty package, and so we can do that here. Catkin, copy this. Catkin create version. So I'm going to make a package called foo. And this is what's in foo. cmakelist.txt include, which is empty, package.xml, which has defaults in it like cmakelist, and source, which is empty. And then when I go up one level, it's going to go and inventory all the packages that are in source. It makes a list of them, and then it goes through and it builds them all. And in this case, there was nothing to build in the new package, so it didn't have to do anything. I'm not going to spend time talking with you about this, but the tutorial talks about the structure of the package.xml file. So the package.xml file primarily specifies dependencies that you need. So these are ROS package names for doing the compilation and runtime. So it specifies compile time dependencies with these build depends and run depends, and that will be in source foo. Right here. So this is the default package.xml, and it's specified that I need these packages for to actually build, and these packages for exporting, that's new, and these packages for execution. Okay, indirect dependencies. The tutorials are going to cover ROS pack depends foo. So the package that I just created shows here the first level dependencies. So ROS pack is a command line tool. We created a package. Once we ran catkin make on it, catkin inventoried everything, and ROS pack depends one gives the first level dependencies of the package, so it depends on the ROS CPP, ROS Python, and standard message definitions, which are each ROS packages. And if I do ROS CD to any one of those things, it'll bring me to a package in op-ROS. And that is a consequence of when I created the package. I lost the command. When I created the package, I did cat can create package. My command line was foo. This is the package that I created, and these are the 3 packages that I told cat can create that the packages were going to depend on. And so now we're seeing the results of that when we introspect into package foo and what are the first order dependencies. Those are the 3 first order dependencies. In the tutorials, you're also going to review the cmakelist.txt file, which was created when we did the package creation. And when we did the package creation with the cat can create package, these are the 3 packages that we said that it would depend on, C++, Python, and standard messages. Everything else here is commented out, and in the course of this and subsequent tutorials, we'll start using each of these directives in order to specify things like standard messages, specify, oh, I have a source file that I want you to compile into an executable, I want you to add link libraries, things like that. That'll happen in cmakelist.txt. And there's also a facility for doing tests, so when you do after you do the compile, it can actually run some code to actually do tests and give you test results. That's an advanced topic that we won't cover this week, but it is a useful function. And going back to the command line, ROSPack depends one. These are the packages which are first order dependencies of our new package foo. And all the dependencies, if you recursively do the dependencies, are these packages. So all these packages need to be installed on the system. And all of these packages are installed on the system in opt-ROS kinetic. So that's where the actual files for these things live. Building a ROS package, understanding ROS nodes. So I've covered the high point of these 2 tutorials. Has everybody been able to source their environment variable bash RCs? Okay. Let me just briefly cover that because I saw some heads shaking both ways. So in my bash RC, so in my root level directory of my account.bashrc, we want to set, and you can do this on the command line. So I'll show you. It's worth doing this. I'm going to create a new shell. Bigger? How about 20? Is that okay? Or should I make it bigger? So this is a clean shell, and if I say print, print environments, we get a lot of stuff. If I grep for the ROS stuff within this, so print environment grep ROS. So the only things that are really set up here are just things that were name confusion, happen to have ROS. And in my bash RC, I set these 2 environment variables, ROS master and export ROS5P. So I'm going to comment those out also. So it'll be clean. And ROS. So now there are no environment variables that have the name ROS. And by default in your bash RC, you want to have this. So it gets executed every time you create a shell. And when we do it manually, ROS kinetic, kinetic setup dot bash. It sets some environment variables, and now we've got these environment variables. So we've got ROS root, ROS package, ROS master URI, ROS list, ROS distro, kinetic, and etc dir. The one that's most important is the package path right here, and the ROS master URI. That's where it's going to look for ROS core by default. This IP name and this port. We'll get to that in a minute. But ROS package path is where it's going to look for packages. And so right now it's going to look for packages in one place, which is op-ROS kinetic share. And I have a local workspace called ROS Catkin workspace that we were working in here. And so normally I then want to, as a second line, source the setup.bash that Catkin make created for me in this ephemeral directory. And when I source that, so I'm going to source ROS Catkin workspace devel setup.bash. Now when I grep the environment variables, notice the ROS package path. The first entry in the package path is home LW ROS Catkin workspace source. That's the first place it's going to look for packages. And then the second place it's going to look for packages is in the system directory out in op-ROS. So this is called workspace overlay in ROS. And normally you work with one local workspace, but there are times when it is convenient to have multiple workspaces, and you can overlay as many as you want. And this is the ROS design pattern, which allows you to have a local copy of a system utility, and you can mess with it to your heart's content, and you'll be working with your local copy. Every once in a while, the ROS makes a cache of where things are in the package path, and so every once in a while the cache doesn't get updated properly. And so if you do ROS CD, if I do ROS CD to foo, I should get to foo in my directory. But if I get to the wrong one and I don't think it's giving me the right thing, then ROS pack profile will rebuild the cache that the system knows about. So if something seems odd about where it's including an include file from or something like that, it uses a cache, and you can regenerate that. Normally it regenerates the cache when you do a tab completion on a package name. So when it hesitates for about a second when you do a tab completion on a package name, normally the second time you type tab, it rebuilds the cache behind the scenes. Get to this in a second. The last two environment variables that we want to set in our bash RC is where the ROS core is going to be running, and what IP address and port number, and that can be any IP address and any port number, any IP address that you can route to, and any port number. But by default, the port number is 11311, and the IP address of my PC on this network, on the TurtleBot network, is that. And if you want to be able to access my ROS core, you should set your ROS master URI to this. So if you want to introspect into things that we're doing in the next 10 minutes, set your ROS master UI to this, and then this the ROS IP or ROS hostname wants to be set to your PC's IP address, and of course you'll figure that out with ifconfig. And so the wireless IP address of my PC is right here. It's on the wireless Ethernet adapter, and your IP address will be different. While you're working on your PC, and in particular tomorrow with the EduMIPS, if you want a persistent IP address, if you want us to reserve an IP address for your MAC addresses, so you're not having to introspect each time, just let me know what the MAC addresses you want me to reserve, and I'll reserve some IP addresses for you on the router, or Andrew will. So building a ROS package, understanding ROS nodes. So a ROS node is a main, and the basic ROS node that will run is called ROS core. And so it's simultaneously a broker that keeps track of what topics nodes are publishing. It also provides additional facilities of its service parameters, and it provides logging utilities for a facility for logging. And you need to have at least one ROS master or ROS core running. And when you do, and you have your environment variables set, then you can use ROS commands. And I handed out a cheat sheet, for example, ROS topic list lists the topics that are available that are, by default, the ROS core has 2 topics. ROS node shows that we've got just one node running called ROS out, and so that's the name that ROS core is known by. It's a little confusing, but that's ROS core. And there's one of those running by default. A more advanced topic is you can run multiple ROS cores on multiple machines, which you might want to do if machines are coming into contact over an Ethernet, and then that Ethernet connection is severed. So there are times when you might want to do that, for example, with vehicles that come and go. And so ROS node ROS node also gives you information. So we just got a passel of information. So ROS node info ROS out. It says that ROS node is publishing ROS out ag. It's subscribing to ROS out, and it has 2 services that are available for setting debug levels. And so the way this sort of debug information, warning, error, fatal error messages work is nodes publish those errors to the topic ROS out, and then ROS core aggregates all of those and publishes them all on one topic. So if you subscribe to this topic, you get all the error messages from all the nodes. And ROS run, also all the ROS commands. ROS run is the first command for running a package. ROS run, turtle sim, and if you're connected into my ROS master, you can type these commands. So ROS run, the syntax is package name and node name. We can use command completion, like turtle. How many turtle things are there? There's a lot. Turtle sim, and within turtle sim, there's only a few things. We're going to run the turtle sim node. So command completion to that, and that pops up this graphical little thing. Okay, somebody was running a turtle sim, and I killed you. Sorry about that. You can't have 2 node names running in the same ROS core, and there's a command line. There's a command line argument to give a specific node name when you're running multiple instances of the same thing. And there's also one to give it. It's called anon, which means just give me a unique node name. I don't care what it is. I just want it to be unique, so I can run 100 of these processes. So by convention, the nodes each need to have a unique name, and there is a facility for making that automatic if you want to. And so you go through this, and now if we open up a new shell, now we've got 2 things. Somebody out there is listening to a ROS topic, and turtle sim is a node, and so there's a ROS topic command line. This is okay on somebody's computer, and turtle sim is the turtle sim ROS out, ROS topic are the three nodes. ROS topic list. We've got turtle1 command velocity. That's a twist message that you send to the turtle sim to drive it. And pose is an output, and so we can say ROS topic echo turtle 1 pose, and you can do this, and you can see that it's spewing out these pose messages, which is a custom message: x, y, theta, linear velocity, angular velocity, at a produces rate. How fast are they coming out? Let's do ROS topic hertz. So at about 1 every 15, 16 milliseconds. What's the bandwidth of that data transmission? So 152 kilobytes per second. So one of the nice things about ROS is it's got fairly good introspection. ROS node ping is useful. You can tell some information. It's turtle sim. Not sure why we got that error. And ROS topics. ROS topic echo, I've demonstrated that. ROS topic type tells you the type, publish in hertz. Turtle keyboard operation. Let's run a different package here in another window. So I'm going to run a keyboard program which reads from standard input. So we're having a name clash. So I'll try that again. So there's a turtle sim. Don't run any turtles for a second. And in this window, I'm going to run a keyboard screen that's going to generate a twist. And my turtle sim, stay on top. So when I put my keyboard in the window of that, I can generate keystrokes forward. And then over here, I can say ROS topic echo turtle 1 command velocity. And with this in focus, when I type, each time I type a key, it gives me a twist here with a linear and angular velocity. And now when I look at the turtle 1 pose, try that again. So when I echo pose over here, now when the turtle drives around, things will be happening. So questions? RQT graph is a useful utility. So this shows right now that I've got a turtle sim which is publishing to ROS topic pose, and my keyboard crashed because somebody ran a program with the same name. If I refresh, then what we can see is that I've got the turtle teleop keyboard thing running in this window, turtle sim running in this window, publishing to a ROS topic. And you can echo, somebody's echoing to this directly, and I'm echoing to this one. And this is a ROS topic echo that got detached because the process that it was subscribed to went down and up.
So if we launch our own sims, we'll ignore, they subscribe to the same topic that you're driving yours with. I really
Yeah, if we run multiple turtle sims with unique names and they subscribe to the same command topic, then they'll drive exactly the same way.
And the subscription topics is managed in launch file on the command line, or?
In these simple examples, there's a default name of a topic that something subscribes to and they publish to, and then you can override that either on the command line or in launch files. And then something we'll talk about later, when you're running multiple instances of things, normally you use namespaces, and so the name of the node and the name of the topics will all be hierarchical. So you could have robot1 command velocity, robot1 state, and so robot1 would be the namespace thing, and there's a namespace argument in the launch file. So it makes it relatively civilized to have multiple instances, and it handles the node names, the topic names, and the service names all in the same hierarchy, using the same design pattern.
Another question earlier. Is there equivalent or a practice for things like make install, make clean? Is there equivalent or?
Yeah, so make clean is remove rm-r build space develop.
But that will delete all of the packages in that package?
It defeats it deletes the compilation products.
But for all packages.
Correct. But I find that when I'm working, and so I find that if I have, for some reason I have to have a giant set of stuff working in my local workspace, I might run 2 workspaces with part of it that is very stable, and I only need to compile once, and then sort of an active workspace which is overlaid on top of that with the part of the tree that I'm actually working on actively, and it will separate those 2 things. Okay. So let's see. Let's get back on track and hopefully release you guys to work on stuff. So you'll work through some tutorials experimenting with the turtle sim, and the code that that I'd like you to write will actually interact with them. And let me just show you my example. Source. So I've asked you to create a package called Beginners Tutorials with cat can create package. And forget about services. Let's focus on topics and messages. The 3 things that you need to create are, you need to create some message files. So a custom message, in my example, is in the message file called num.message. And so this is a specification for a message which consists of just 2 floating point 64 numbers. And in the cmakelist.txt file, we'll make a few changes, and the tutorials walk you through this. We'll tell cmake that we want to make messages from the file num.message, and so it's going to generate C code and Lisp code and Python code for serializing, deserializing that message. And once we do that, we can say ROS And so I said ROS message info. I've done a catkin make, and so the system knows about a message which is in package beginner tutorial, and the message name is num. And it's telling me that it's 2 float 64s. So how do you actually publish and subscribe to things? In the source directory, this tutorial actually really gives you the code. And so this is the source code that it gives you. This is the basic way to write a ROS C++ file. Is and actually I'll show you the version that they do first. Source. This is the example that's given in the tutorial. ROS.h, standard messages string.h, and this is the normal design pattern for including things. Where if there's a header file which is unique to a package, the design pattern is that you say include package name / header file name, and that's consistent. We want the stream include. ROS doesn't wrap main. ROS init initializes the system, and it tells ROS core the unique name of the node, and a launch file can override that name. And we're going to create a node handle, and a node handle is a function which contains a bunch of, it's a class that contains a bunch of member functions for publishing and subscribing and interacting with the ROS system. And the way in the example given here, what they do is they create a publisher called chatterpub, and it's going to publish a standard string message. The topic is going to be called chatter, and it's going to have an output buffer of 1,000 messages. And this is a loop rate delay mechanism for sleeping for 100 milliseconds, so a 10 hertz loop rate. And this is actually bad programming, because what they're going to do is they're going to wait here with a delay, and they're going to publish a message. So while ROS is okay, so while the ROS system has no errors, nobody's typed Control C, they're going to create a message string that says hello world followed by a count, and they're going to, this is the ROS design pattern for publishing information messages. The lowest, that's debug level 2. There are 5 debug levels. 5 is fatal. 1 is debug. Info is level 2. And if you echo the ROS topic, the ROS out ag, then you'll get all those messages. And there are tools for introspection. And so chatterpub is the thing that we created up here as a publisher. And we're going to call chatterpub's member function publish with the argument message, which is that string. Spin once means service any callbacks that are pending for any callback functions, and none have been created here. And this sleeps for 100 milliseconds and loops. Now, this is actually bad programming, so I'm sorry about this example. Because what you should really do is you should create a callback timer that gets called back every 100 milliseconds. And so the example that what you should really do is this. Your main should be very simple. You should create a callback function. So node handle, create timer, ROS duration is 100 milliseconds, and the name of the callback function is timer callback. So it's a regular callback function. And then you block forever on this thing called spin that services callbacks and timers and everything else. So this is a better design pattern. And hello. Give me a second. Yeah. So a better design pattern would be to, here, the whole main is just here. We do a ROS init. We create a node handle. Create a callback function that is going to be, we advertise that we're going to publish on a topic called chatter, and a callback function that's going to get called every 100 milliseconds and then block forever. And the callback function does what you'd think. It creates a message. Wiggle that HDMI connection. And the callback function here, timer callback, it's going to be called every 100 milliseconds. It creates a string message. It publishes it twice, once as a ROS info message, and here's where it actually publishes it on the topic. We'll use this screen. Good reason to have two screens. And now, when we type ROS, let's see, we need a. I'm going to need a ROS core. And when we type ROS run, beginners, tab completion tutorials, tab completion twice. Those are the things that I can run. Talker is the name of the program that we just looked at. And ROS topic list. Now we've got a chatter topic, and we can echo chatter. And so there they are. And so on your machine, you can type ROS topic echo / chatter, and you should be able to see it. And so here's what's happening. I'm running Talker on my machine, publishing on Chatter, and right now there are 3 people in the room who are echoing, and so their command line nodes are being registered with these ephemeral names to make them unique. And if I update, there might be more. Oh, somebody just killed one of the nodes. You need to hit the little update thing here. So the last thing I want to cover is so this thing is publishing away, and how do we subscribe? We don't. So the example code in the tutorial that you're going to look at looks like this, and it's not actually bad code. It's a very simple program. Again, we're not wrapping main. You do a ROS init with a unique name. This name can be overridden on the command line with ROS run or later in a launch file. You create a node handle, and in this case, we're going to create a callback function with an input buffer of 1,000 messages. It's going to subscribe to the message chatter, and it's going to call a function called chatter callback, and then it's going to spin, which blocks forever servicing calls. And the callback function just does this. It reads the message, and it generates a ROS info message. So it's subscribing and publishing. And so this is turning away here, and we're echoing in this window in the lower left. And if I say ROS run beginners, tutorials, listeners, then it runs and it subscribes, and RQT graph now shows that I have a this is the node called Talker. It's publishing on the topic called Chatter, and this is being subscribed to by listener. And I can say ROS topic echo chatter, and there they are. ROS topic list. Chatter is there, ROS out, and ROS ag. Let's look at ROS out. So these are where the diagnostic messages are being published. And we can see the diagnostic messages. These are all at the info level, which is level 2. Level 1 is debug. Fatal is level 5. And so by default, there's a message type for these things. There's a header, timestamp in seconds and nanoseconds since 1970. All ROS internal time is UTC, so ROS bag times are all UTC. It doesn't matter what you set your local clock to. That's a good thing. And it says the node listener gave this message. It tells you the file that it was compiled from and the function that it was delivered from in the line 9 of that file. So there's a bit of introspection there that is done for you when you use those ROS messages to log. The tutorial asks you to also do a construct a ROS C++ node for a service client and server. And I'll just mention that what they are is the ROS communication. Any number of nodes can publish on a topic. And so it's a free-for-all. You, the programmer, need to control who publishes on a topic. A topic should always be one message type. And any number of nodes can subscribe to a topic. But it's a one-way communication. And if you think your node's going to be busy doing something, some complicated computation, then you probably want to set your input buffers when you subscribe to a topic to a large value, so that they'll queue up. And if you do a good design pattern where you're doing a ROS spin, which blocks forever, then you don't need to have large input buffers because it's going to be servicing things all the time. A service, but this is a one-way communication. When your ROS node subscribes to a topic, that's when the negotiation happens. It subscribes to a topic, asks ROS core, does this topic exist, and if it does, where do I get it? And then it actually establishes a direct TCP connection to the source. And so all things do not go through the master; they go direct. And if you want to, when you subscribe, you can ask to subscribe via UDP. The default is TCP. So if you want unreliable communication, then that's there and supported. A service is a two-way. It's known as you call them a remote procedure call or a rendezvous. And the idea with the service is a message with two parts. And when a client makes a service call to a server, it makes a call to the server. It blocks the first part of the message, the data that it's sending to the server, like I want to shift from forward to reverse. And the second part of the message is what comes back as the response to the service call from the client. And so it's an atomic operation. And when you receive the return call from the blocking call on the service, you know that whatever transaction you wanted to do with the server has completed successfully. And so that is important in some cases. It's generally not important if you just want to say, well, what's the latest frame what's the latest data point from the CTD? But it could be really important, such as disarm the drop weight. Like you really want to know that got disarmed. Questions? That I spent more time on this than I intended to, so I apologize. Yes.
In the case of the drop weight example, you said the service already was blocked.
Yes.
I don't know, suppose you have a concealed protection or something.
So there's a timeout.
You still want to make the comment.
So there's a timeout call where you can say block for this long or fail, and that's what you want to do there. I took longer of your time. I wanted to try to finish up by 9. Didn't manage to do that. I apologize. But what the plan is for you to basically work through these tutorials from wherever you got, and ideally get to a point where you're writing C++ nodes and working with topics. Don't worry about services right now. Topics are what are important here, and the design patterns. Comments and suggestions, questions? Am I covering things at too fine-grained detail, too high level, too low level?
You gotta go through it.
You
have to go through it.
All right. Well, It's 9:34, and you're free. Andrew and I will be available. We'll be wandering around. Please make use of us. That's why we're here. And go for it. Yeah, no, so we need to give ROS okay, which makes so you have right access to the sets. So it doesn't have to be a technical. So they know the cause ROS okay to do that. And then everybody else is going to.
I'm just kind of curious, like, on the system, that was kind of the way it's going to fire up. did on this machine, I did install, the lumen distribution. And then left that one mistake. Uninstalled it and installed it again. And I don't think they're that, definitely, they're pretty good.
And you can
The hook is slash off.
Technically, the tutorials have lost months.
Yeah, I thought that one was wanted to do it.
You can't have two of those. So that was some good, putting in your structurals and frozen or that.
Yes, okay. Second person did sound like the first one. So there's
This is just on that little note, but.
Yeah.
Hopefully.
Is it possible to put it on the code for the proper talker, just because that's not on
Yeah.
tutorial?
Mm-hmm.